We're going to begin the discussion of symmetrical components in a place engineers typically hate to begin, and that's the philosophical background. So, no formulas for this video, just explanations. No data, just ways to think about something. Gross, right? Well, we really have to do this because it doesn't seem to have been done before, at least not in a way I've ever seen. And engineers actually seem to struggle with the concept and application of symmetrical components because they want to jump right into the formulas and get calculating. They want to pass over the prior explanation of the subject matter and get going. And we get it. We know that that's what you want. But we're really not sorry, but we do get it. What is symmetrical components? Symmetrical components is a method. It is a method. It's a sort of series of steps that, when followed, will allow you to analyze an entire electrical system. You can use this method to find current or voltage at any point in an unbalanced polyphase system. And unbalanced is vital here. Why is unbalanced vital? It actually could be employed, that is, symmetrical components could be employed under balanced conditions, but you really wouldn't want to, unless you like pain and tremendously long calculations, because it's far too complicated of a process, provided the system is balanced. You have much simpler means to do your circuit analysis under balanced conditions. So really, it finds its most useful application when the system is unbalanced. Symmetrical components is a circuit analysis method used to simplify an already complex circuit. So it's kind of similar to Thevenin and Norton equivalencies, and it's also similar to things like the superposition methods and the node mesh analysis, etc. So it's just similar in the way you think about it. So your frame of mind when thinking about symmetrical components should be sort of like that, like the way you would think about Thevenin or Norton or so forth. Symmetrical components is a super complicated and in-depth mathematical exercise when you take it from the very beginning to the very end, as shown here. Thankfully, the PE won't really ask you to do a full symmetrical components analysis. Thank you very much, NCES, for changing the test to multiple choice on this one. So you will be asked on your test really about portions of the methodological process or general conceptual sort of non-mathematical elements of symmetrical components. Another way to sort of think about this in preparation is these questions really should be answerable in around 6 minutes. That is, the PE-style NCES test questions really should only get about 6 minutes to do the calculation, considering the time constraints you're under. So to do a full symmetrical components analysis would take way longer than that. So you'll only really be asked to do bits and sections of what is the symmetrical components method. As if all this talk wasn't bad enough, we're going to now talk about the words. What does the actual term symmetrical components mean? What are the components? And what is or why symmetrical? Well, the primary analytical focus is on the phasors when we're doing a symmetrical components analysis. So what is meant by components, quote unquote, is the components that make up the individual phasors. And when these components are assembled in the analysis, they must be symmetrical. This means that the component phasors we'll work through require symmetry. Now, symmetry is not found in the original phasors. For example, the unbalanced situation shown here. And we're going to get into this in detail much later, but we'll see here that these unbalanced phasors can be broken up into 3 phasors, which then can be reassembled in symmetrical ways, shown here. Once again, we'll get into this in much more detail later. But it's important to understand that one of the controlling factors in how these component phasors are generated, that is, what their magnitude and phase angle will be, is the symmetry. This symmetry affects the magnitude and phase angle of the component phasors. So we take something unbalanced and transform it into a symmetrical construct. Now we realize that what we've talked about here doesn't necessarily seem like it will apply specifically to the PE, but it really is sort of a confusing subject matter, and we needed to give this preface video. In the next video, we really are going to roll up our sleeves and get into a PE type questioning and some of the specifics you're going to need to know for the PE tests. So thanks for your patience on all of this, and we're going to carry through in the next video.